Now let's get familiar with the rules of engagement for day one. This simulation will have resources that remain the same over the next 3 days. For workstations 1 through 4, they are assembly stations. We have one operator for each of these stations. At workstation 3, we have a need for a setup. Workstation 5 is an inspection station. We have one inspector at that station. Workstation 6 is for shipping, teardown, and recording, and we have an operator there recording the information. We also have 2 industrial engineers. They are calculating the cycle time and lead time through the process. These industrial engineers are using a stopwatch to make this calculation happen. Next, let's take a look at what's going to happen during day one. We build in batches of 5. The reason for this is because our computers determine the economic order quantity is 5. With that number, we hope our cost per unit is less. Batches must remain together through to final inspection. This means that the batch must be built and transported from one station to the other right through to workstation 5 and then delivered to workstation 6 for shipping. Operators themselves must deliver the batches to the next operation. They can't move the planes across the table because that's a safety concern. They have to get up out of their chair and deliver it into the queue of the next operation. That means workstation 1 must get up out of their chair, deliver batches of 5 to the queue of workstation 2, and so on. Operators must procure their own parts. Soon as they run out of parts, they need to go to raw material stores, get more, and bring it back to their station. Operators must maintain a steady state of production. That means after an operator delivers their 5 planes to the next operation, they must go back, sit down, and keep on producing. We pay them to work, by the way. At Station 3, a setup is required. We also call this a changeover. We try to do this very consistently each time so that the quality of the product remains the same. We need to go through a standard operating procedure with very specific rules on setup so that the time is taken into account as well as the quality of the product each time. The inspector must identify quality problems and set the planes aside. They can't communicate with the rest of the plant, and of course, that's not unusual, is it? At Station 6, the operator does shipping, teardown, and recording. That operator considers the product shipped at that point in time. They record the information needed for production numbers at the end of the day. This feedback is given to production to indicate how well they have done. All right, now let's begin by starting the simulation with a practice run. We're going to let everybody run a batch of 2 aircraft down the assembly line so that everybody gets used to the process.
Welcome, fellow lean thinking enthusiasts. This is the SBAC training session. During this time, the operators get used to the duties of their workstations. They will run a batch size of 2 airplanes through the system. The operator from workstation number 1 makes 2 errors, thus costing his team valuable time. He builds 1 plane instead of 2. The required batch size is 2. This is inappropriate processing and is a waste. His second error is that he hands his subassembly to the operator in workstation number 2 rather than placing it into the queue. This just won't do. The operator in workstation number 2 is now forced to wait while he goes back to correct his error. This is a demonstration of 2 more wastes: waiting and transportation. Flawless execution by the operator from workstation number 2. Note the proper delivery of his subassemblies into the queue area of workstation number 3. Oh no! It looks like Operator 3 has forgotten to use the checking fixture in order to check the airplane lengths. This will cost her team some valuable time unless she can realize her error and recover quickly. Some unnecessary motion, but nice recovery, Operator 3. Now she must make haste and round the table to deliver into the queue of workstation number 4. Uh-oh. Sorry to tell you this, Operator number 4, but you just made a fatal error. This is going to cost your team big. Operator number 4 neglected to install the airplane rudders. A feeble attempt to sneak the missing parts over to workstation number 5 is made, but as we will soon see, quality control will have nothing to do with this kind of tactic. The inspection continues. Operators converge on the quality control inspector in a last-ditch attempt to influence his decision. They urge him to make the repairs himself and pass the planes as complete. Let's see what he does. Quality control will not bite. The airplanes have failed the inspection. What's this? It looks like the LEGO simulation facilitator has overridden the inspector's decision and has allowed the planes to pass. Don't expect this type of grace to be demonstrated during the actual LEGO simulation. There's only one name for incomplete assemblies such as these. It's rework. This concludes our viewing of the SDAC training session. Stay tuned. Next we have the Day 1 LEGO simulation highlights. Remember, folks, keep those unforced errors to a minimum.